This next presentation on the Ed Gray Purple motor, I guess kind of been a long time coming. I know that when these motors were first made available, the blue one that Al Francoeur has and the purple one here, I think John Riley, who somehow got his hands on them through some estate deal or whatever, I was basically the first person, I believe, that he contacted to purchase these motors. At that time, I didn't have the money and didn't have that much interest in these particular motors because I didn't really understand the whole history of what was going on. But the whole Ed Gray story kind of, in my world, kind of happened in the early 2000s. Peter had come out with a book called The Free Energy Secrets of Cold Electricity, which I guess you could say is kind of his thesis on how he saw the technology working. And then soon after that, John Bedini said, well, you essentially have it correct. Here's my drawings. John Bedini went and visited Ed Gray with his friend and partner Marvin Cole years ago. I'm sorry, Ron Cole. Too many Coles. And with him and Ron Cole, and they were able to analyze and look at it. And John had written up multiple diagrams on the gray motor, the gray tube, how it was switching. There was this interesting diode that everybody said he drew in the wrong direction, which he didn't. At that time when I looked at the drawings, I didn't know too much about it or how a diode really was supposed to work. And that was the only thing that ever really made sense to me, and is how I came up with the little plasma ignition circuit, which is kind of an analogy of that circuit. After a while, Al Francoeur wound up with the blue motor. Reggie has had this one quite a while. I think Reggie contacted me years ago about this, and right around the same time, Mark McKay, or after John put out those drawings, somebody named Gary McGrattan had been doing some experiments and posted it online and said if anybody writes him, he'll send his report of his experiments. And when I contacted Gary McGrattan and he sent it to me and he saw I was in Spokane, Washington, he said, hey, there's somebody else in Spokane, Washington experimenting with this. So he put me in touch with Mark McKay, took my friend Jeff out there. Jeff happened to know Mark's one of his family members. And Mark had given me a few parts to experiment with, and I think we went into the back of one of the trailers that was kind of set up where Mark was doing some experiments. And from then Mark was so passionate about trying to get to the answer of what this gray motor business is about, and went on a journey for, I guess, several years, meeting Gray family members, engineers, investors, trying to get to the bottom of the story. He's presented, I believe, 2 times on emediapress.com. There's the history of the EV Gray motor. You can find that on eMedia Press if you want to see his previous 2 presentations. This particular presentation is going to be specifically the history of this particular motor, because each motor has its own, each color-coded motor has its own very unique history. Mark is the world's leading authority on the history of the EV Gray technology, and actually 12 plus years of analysis of this unique free energy phenomenon has opened up new possibilities into reverse engineering this powerful yet lost discovery. Mr. McKay has 35 years of engineering experience in industrial power and control systems. He received a bachelor's in science in electrical engineering from New Mexico State in 1974, and is a professional engineering in the state of Washington. Please welcome Mark McKay.
This one here. Well, good morning, all you fine faces. Thank you for getting up early in the morning and coming to see this. Kind of give you a short overview here. Many of you have furnaces or air conditioners in your house. All the motors that are in those devices have a quantity called COP of about 0.41. COP, it stands for coefficient of performance. Basically, it's a measure of how much energy goes into the motor and how much effective energy comes out to move air through your house. Now, the great breakthrough you were able to demonstrate this morning was Reggie's reluctance motor, which is a great improvement on the technology. It has a COP of 0.91 from just recent laboratory evaluations. I mean, that's going to cut the energy usage of motors from what they are classically now for a single-phase induction motor, cut it in half. And even just a half of what's currently used for motors is going to be a huge boom to energy reduction. This technology is something else. At the peak of its development, this motor was producing a COP of 300. I mean, that's science fiction. The technology here is strictly non-classical. You can't use your, it has a lot of things that use classical calculations, so you gotta at least know your basic electronics to work it. But once it reaches the non-classical event, I call it the radiant event, you're off into another world. And not very many people, least of all myself, have been able to figure out what that is. Now, Reggie's motor out there, that is a classical magnetic process. This is something else. The forces that are generated in this device are 3 orders of magnitude greater than what you can achieve with a classical magnetic field. Well, if we have yet to know what that is. So this is an age-changing technology if it wasn't destroyed or wasn't ruined accidentally by ignorance. We'd be living in a completely different world, and if we can ever crack the nut as to how this thing did its thing back then, we would be living in a new world. The whole energy, oil issue, and all the geopolitical processes would probably be vastly different. So I'd like to go over the history of how this particular motor came about and kind of broadly touch on the overall technology that was developed and then lost. Okay, so this is the purple motor. This is what it looks like from the side. Okay, this motor was not made in isolation. It is the 5th generation of a whole series of motors that started construction in about 1971 and was based by an inventor named Marvin Cole. This is the earliest picture I could get of that motor. I don't know what the EMA-1 and the EMA-2 look like, and I don't even know for sure if they ever existed. But this is where it started. This one was about 1971. Then he came up with some better ideas, and he developed the EMA-4. This one here is the one that sets it apart from any other free energy technologies you might have been exposed to. This device was tested at Caltech by a company called Crosby Research that actually specialized in testing inventions. They consulted with 2 PhD electrical engineers that worked for the Jet Propulsion Laboratory. These guys specialized in power supplies. They worked on this thing for 10 days and made all these measurements. That's where they came up with the calculations of the COP of 300. So I don't think very many other free energies are vetted to that particular degree and come up with this kind of performance. Then they went on to, then Marvin Cole left the project. It's been speculated by me that he discovered there was an anti-gravity process here, and that was too much for him to handle. So then Gray, who was the promoter and money man, hired a classically trained engineer named Richard Hackenberger that got his degree at Southern University, his master's, and was working in Silicon Valley. His specialty was transistors and making things like that. Well, he took that technology that Marvin Cole had, and he built his own motor. This is called the EMA-6, which was on display in 1976. Unfortunately, he had a few bugs to work out. This thing here, when it was demonstrated, only put out 2 horsepower. So Later, he was working on it. They finally got it going pretty good, but when this thing, with this non-classical process, it generates all these forces, also generates a lot of EMI. So the FCC descended upon them, confiscated all the motor, run it through a shredder, and it was never seen again. Well, that didn't deter him. In 1979, he got Gray and Mr. Hackenberger and Gray's oldest son, Mark Gray, got a huge grant from to go to Dodge City, Kansas, and manufacture this whole series of motors. And you can see the purple motor is right here. But you have the white motor, the gold motor, the black motor, and there was a blue motor that's not pictured here, and one at the end that I don't know what it is. And then another motor that's not pictured, it's just the case. So that was this was the zenith of the technology. Each one of these motors were designed to explore a particular aspect of this technology. They were trying to really branch out. The black motor at the end here just has one set of poles, and it's got an opening on the side so you can actually see the timing and the effect of what's going on inside the motor. The purple motor here was designed to have everything plus an energy recollection system. The white motor was all plastic. The gold motor was the same as the purple motor, except it didn't have the energy recollection. And the one down at the end, I don't know what it is. It looks like the first prototype they built just to get started. Okay, now we'll go into the actual history as the best I could determine what happened. This kind of took place all over the country. Okay, this is Richard Hackenberger, a photo that was taken in 1973. Here he's demonstrating a popping coil device for a technical reporter. This is the man that actually designed this motor and had it built. I'm sure I would like to meet him. This is where they did it, in Dodge City, Kansas. This is where the money man was. And this is the money man. As far as I can tell from the number of people he was hiring, the number of machines he built, paying for room and board and motel for Gray and Hackenberger and his son. They had a little company going there too, and there was a mad dash to buy all this stock. So that's a whole business scandal in itself. But anyway, he saw this and it just blew his socks off. He had the money and the time to really dig into this, and he was a critical player in this whole saga right up to the end. Well, there was a financial dispute with the players and what was going on, and everybody was trying to get ownership and control over the technology. There was no patents produced for any of this stuff, so whoever had it had the golden goose. Well, Gray and Mr. Hackenberger decided that they've had enough. They're going to take all their motors, load them up in a truck. So on Christmas Eve, in a very cold winter, they loaded it up and hauled ass out of town and hid out in Portland, Oregon for 6 months or so. They eventually ended up in Canyon Country. But it was a very cold trip, and Mark Gray describes how Mr. Hackenberger was trying to get the fuel nozzle to fill up the truck and couldn't do it because he was compromised by the temperatures and probably the stress of having to stay up all night and drive across country. Well, unfortunately, that exposure, he got sick, he got the flu, and he died when they were somewhere in the Portland area. His family, who was also in Oregon, didn't know about his death for like a month. And so all that expertise, all that knowledge was lost. His brother eventually ended up with his lab notebook, but after 10 years, nobody was interested in it, so he tossed it. But he did remember one sentence, and he had notes in his book that said, "This stuff works, but I don't know why." So that points to the non-classical nature of what they ran across. Well, Gray, he's not going to let a good thing go to waste. He took all the motors, of which there was about 6 or 7 of them in that truck, and set up shop in Canyon Country, which was right there. As American Home Medical Equipment, because obviously Mr. Audrey was trying to hunt him down to get his $2 million investment back. But the motors, for some reason, didn't work, or at least they didn't work as well as they should. He had problems. Mr. Gray was not a technical person. He didn't even know Ohm's law. So he thought that he could just go right out and hire a technician off the street and say, go fix that motor, I want it running. Okay, well, so this gentleman here, Mr. Nelson Schloff, who I had the fortune to interview in 2006, took the job out of the newspaper. His background was he was an aviation electronics technician. Well, the sad part is Mr. Gray did not tell Mr. Schloff what the purpose of this technology was. He was told it was going to be an electric motor for cars, and he wanted him to get it running. So he looked at that thing, and at the time, the motor had been running. Gray hired another engineer, also named Richard, that was able to figure out how to work it and get it going. And the original motor itself had thyratrons on it that were used to trigger the ignitrons. Mr. Schloff decided that, well, you can't have thyratrons on there because this is going to be in a car and it's going to vibrate and going to mess up those thyratrons. I don't know what the vibration would do on the ignitron, but apparently that wasn't an issue. So then he looked at the electromagnets that are in this motor and decided, oh, this wire is way too fine. You can't get enough current through this. So he went to the machine shop next door and he had them completely rewire the electromagnets. He told me that the original wire on these electromagnets were about 19, 18 gauge, maybe as even as small as 24 gauge. He wasn't sure. But he figured that he needed 14 gauge wire in there, so he took out all the wires, rewound them as simple solenoids, a 14 gauge wire, hooked it up, and by golly, now the motors would start from 0 speed and they'd go in the opposite direction. Well, that's good and great. The only problem was it took 10 kilowatts of power to run this motor in that configuration with no load. But to Gray, that didn't matter. The thing started and it went backwards and forwards, and he thought he was ready to go. Well, Rocky never knew until I interviewed him 23 or 6 years later that the whole purpose of this technology was free energy. He had absolutely no clue at all. So inadvertently, he went and destroyed all these prototypes completely unknowingly and innocently, trying to do his job because Gray didn't have enough technical expertise or enough management ability to steer him in the right direction. But Gray at the time thought he'd really cut a fat cow. So he goes on to try and sell these motors across the country because he had the lab reports from the Crosby research that was done at Caltech, which was very impressive. And then they had a whole bunch of research reports from their work at Dodge City, where it was tested, and that's what caused the big financial fervor there. You can see in this video here, he's trying to sell these 3 lab reports that he's got that have all this great and wonderful information. And I'm sure they did, but probably nobody believed him because he didn't have a motor that could perform that good. So he gets the idea that he's going to go and sell this stuff to the Jewish community in Israel. And apparently they had some interest, so he flew over there and made his presentation. And what the real problem was, Gray was not willing in selling the technology outright. He was trying to sell licenses because he figured he could make more money selling licenses and leases and doing that work than actually letting go of the technology. He was so afraid that once any of these things got out, somebody else would take advantage of the simplicity of the technology that was in this motor, and he'd be out in the cold, which is probably a fair assessment, but it didn't sell. So he came back empty-handed. They offered him $9 million for an outright sale of what he had, and we didn't go for it. That was the end of the negotiations. Then he got the idea he was going to sell all the stuff to Congress. So he wrote a personal letter to every member of Congress saying, hey, I got this great, wonderful thing, and I'll give it to you. But nobody was interested because nobody believed the stories, and I don't know if they even took the time to take a look at the lab reports. So that fell on its nose. Well, after failing at that, his health was really marginal at best. He was a chain smoker, and by the time that came around, he was on oxygen. He was in and out of the hospital several times for lung problems. And then one day at the shop that he had at Sparks, Nevada, some high schooler was running a stick along the outside corrugated metal of the building at 2 in the morning or something like that. So he ran out there to confront the prankster. Apparently took a gun with him, was going to fire a warning shot in the air. The gun didn't work, so in panic, he came back in and collapsed in the living room. He forgot to take his oxygen bottle. At least that's the story as relayed by the lady he was living with at the time. So that was the end of Gray. But Russell Audrey, the guy who paid for all those motors, was hot on the trail, and he demanded to get those motors back. So there was these legal disputes that took place over a few years. And getting into more drama, these things finally were collected and went back to Dodge City, and Russell Audrey put them in a shop and hired as many people as he could to get these things running again. He hired Nelson Schloff. He hired Gray's oldest son, and they worked on this for about 1-2 years. I'm not sure exactly how long, but they couldn't get any place with it. The secret was so well contained that even all these people that had been around it intimately for years didn't have a clue. In my interview with Mark Gray, who lives over in eastern Washington, said that he wished he'd paid more attention to what was going on at the time. Well, after these motors sat in a barn for a while, a guy named Kenneth Hawkins talked to the lawyer of the firm at the time and found out where at least some of them were at. So he drove up to Dodge City and was able to acquire the white motor and the black motor, the casing for the E3 motor, a pump, and a few other odds and ends. And he brought these back to his friend at the time, Norm Wooten, who put together a very nice presentation in 2002 showing the parts and pieces and making his comments on it. It was 2000? I thought it was 2002. Okay, well, whatever. It was in that time frame. Okay, I stand corrected. It was in Dallas? It wasn't in Florida. Okay. It was a great presentation. He did a real good job. He had all the parts and pieces taken apart there, and he made his assessment because he's into free energy research of one particular brand or another. And apparently it didn't generate any interest, so he had all these motor parts laying around. Then about a year later, he decided to sell them. So he sold them to Al Francor up in Canada, the guy with the solar cell system that Peter helped build. And he's been working on them and checking them out and trying to restore them by buying hard-to-get parts and pieces for them, like these ignitrons, the capacitors, and I mean, he's got those two motors. Well, the gold motor, the purple motor, and the great big huge power supply that drove these things ended up being brokered out to John Riley, who's also a free energy researcher, a spiritual meditation type guy, who has his own business doing this stuff. He hired another engineer that came in and, for a very hefty fee, analyzed all the motors, at least one of them, came up with a 30-page report of all the wiring diagrams and his estimate of what was going on, which was, again, purely a classical evaluation, and came to the conclusion they couldn't do anything with it, so he put these things up for sale. The original cost of this motor and the gold motor was like $30,000, and I think the trigger cart, where he thought the secret was $125,000. I think that one's still for sale. I'm not sure. It is? Okay. Al, on the other hand, was doing windmill motors. And there was a company that was really interested in that, and they went and bought the gold motor for him to work on, hoping that he could move it ahead. So Al ended up with the gold motor, the black motor, and the white motor. And Reggie bought the purple motor in 2013. I don't know how much he paid for it, but it was substantial. Okay, so that's basically who built it, where it was built, when it was built, how it got destroyed. So now we'll go on to the importance of why this is so important. Well, I kind of alluded to that. Spoiler alert. Okay, the keystone to this whole technology rests in the work that was done by the two PhD electrical engineers at Caltech. And these guys, these two engineers, at least one of them was hired to write the patent for it. And then he went on, and he was still working at JPL, and he ran into Reggie some years later, telling Reggie, hey, this is what you got to look into. That he was totally impressed. In fact, both these engineers became members of the board of the company that Gray had at the time. Intergrave Enterprises, and they had another name to it. They also had a call. They called it Electrotech. So they were wheeling and dealing with corporations. And okay, so this is the crux of the matter. Most people, when they deal with free energy engines, are they're using electricity in, and they get classical electricity out, and hopefully they get more out than what they get in. This technology is not that way. Its free energy output is torque, or force. So here you have the converter right up here. It takes two batteries. You can't have one, you have to have two. Here is the converter, called the engine. It was always called a motor. It's not a motor. And it went and drove a classical generator. So here we have, these are the measured numbers that they reported on. This whole thing took 26.8 watts in and came up with 7.5 kilowatts out. And they ran this for as long as the energy in the battery would last, which was a day and a half or something like that. Apparently they didn't have the switching system set up there, so it would charge one battery and then swap it over to the other. But I don't think there's has anybody else heard of a free energy technology in today's market that has these kind of specifications? I don't think anybody's come close to it. That's why I did some calculations once, and I could be correct, but that's like filling up your car once and being able to drive it for 5 years. That's paying your power bill on your house for 1 month and live in it for 5 years. This is the sort of power energy gains we're giving here. But actually, since you could recycle that, you wouldn't have to fill up your car again or power your house again. Okay, so now we'll get more into the technical aspects. That's probably what you're all wanting to know what's happening. We'll look at the the gold motor, because I've got more information on that than I do this one. They're very close. Like I said, Al Francor up in Canada has the gold motor, and he spent hours and hours taking it apart and drawing schematics up, detailed schematics, and then shared them at the convention a few years ago. And I took those hand-drawn drawings and used AutoCAD and made some readable schematics. Okay, this is the gold motor as he got it. I don't think I had the batteries on it. Here's the elevation. You can see that they're very similar. The only thing that's different is the coloring on the end bell. Okay, the gold motor has the commutator, which is a mysterious component, trying to figure out how it works. But this commutator, they made 5 of them, one for each of those prototype motors. So they were able to get some savings there by using the same set of drawings at the same machine shop to knock out 5 of them. Here's what happens. The purple motor doesn't have the end bell that's being taken off there, so you can see what's on the inside of it. Okay, so here's the contactor points are wired just like they're shown here, except there's 15 contacts, and not all of them are being used. When Mr. Schloff rewound that, he took off everything that he didn't need and left it. So there's a whole lot of control points there that serve some purpose in the original motor that we don't know about, unfortunately. And if you try to figure out why he wired the ones up he did, I can't figure that out either. Here's the end bell coming off. This is the stator electromagnets. Here's the rotor. Here's the ignitron array, which looks just like this. Here's a close-up of one of the ignitrons. These were used in spot welding quite a bit. Al was probably able to get the last few available on the internet. Okay, this is, I don't know if you can see that, but this is my interpretation of Al's handwritten drawings of how the schematic went together. It was pretty simple. All the rotor and the stator electromagnets were fired at the same time. They were fired on the low side with these ignitrons. The upper ignitrons serve the purpose of charging these capacitors. Now, you can see at the top where the power comes in, that 5,000 volts. That 5,000 volts came from a 50 kilowatt cart that was basically 2 huge variacs and a large rectifier and a 5,000 volt transformer. It was a huge monster. It took a 50 kilowatt generator just to run that thing. When Gray demonstrated these motors when they were somewhat operational in Kansas, they just plug it into an outlet to get the excitation power to run it. When he came back 5 years later, after these things had been butchered, he had to rent this generator in order to get these things to even turn. And he didn't even know the difference. Originally, the ignitrons were fired by, like I say, thyrotrons. Nelson Schloff came up with this approach here, where he took Zener diodes, made a long string out of them, took the 5,000 volts and cut it down to 1,500 volts, which is the trigger voltage for these ignitrons, which I think is, it's an improvement there. It's a lot better than trying to manage thyrotrons. I don't know about the speeds, and I don't know if there's other parameters to be involved, but that was an improvement. And those devices are these little cards that are stuck in here. So he uses the commutator to trigger the card, and from there it triggers the ignitron. What's odd about this whole thing is this capacitor charging network. Now notice these ignitrons up here have to be triggered by a transformer because they're on the high side of the load. And what he's got is the power supply comes in, keeps these 2 capacitors charged, and then at various times during the control of the commutator's operation, it charges up this bank of 4 capacitors. So these things get charged with a pulse, and then a few degrees more rotation on the commutator, there are these turned on, and these capacitors are discharged through the motor. Why he did it that way, I don't know, but at the time I asked him what was going on. This was before I had the schematic, And he said that when he got the motors, they were doing this funky capacitor charging system with the ignitrons, except he said there was a battery in there, and they were charging it from the negative end. And he thought he'd keep the same system. He kind of reworked it into this, but previously there was some sort of system or some sort of energy recovering system that required the high current capacity of an ignitron, and the battery was involved. He took the battery out because he didn't know what it was for. So this is what we ended up today, and this is probably how the purple motor was also reconfigured in 1979. Also, an interesting thing is you'll notice there's all these jacks on the side here, a bunch in the front. These things were configured not as complete systems, but as test systems, and all the various subsystems came out on these jacks, so you could hook it up this way, and you could hook it up that way, and you could put a meter here, and you could put a meter there. It was still a evaluation presentation. So some of the other systems, this was the charging system. Now, this particular technology, for reasons I'll explain later, you can't start the motor from 0 speed. You have to speed it up to a minimum of 500 RPM. Okay, so they were able to use a generator, which also served a generator that could also be used as a starter. So in one configuration, you'd turn it on as a start motor, get this thing going up to 500 RPM, have it working in mode, then you could take the energy off the shaft and run a generator to recharge some of the batteries. And this was how they did it. Here's a detail of the ignitron trigger card. Here's showing the outboard relays, which have been removed from this box here because they're not necessary for the main technology involved. Then Nelson Schloff built a timing box. At the time I knew what it did, but it wasn't important. It had to do with how long you turn things, which wasn't necessary. But anyway, he had this timing control box for startup and shutdown. Here's more details of the commutator. And this is what's interesting. This is the design of the actual cores. This was taken apart on the black motor. And Al Francor put this online. It shows some unique stuff there. These are open core coils. These are not closed core coils like what you have in an induction motor. This is much like the induction coils, like your ignition coil and things like that. With the open core design and you don't have a complete magnetic path, it reduces the K factor between the primary and the secondary windings. But you can still look at the shape there and going, what the heck? There's a purpose for that, in my opinion. So here's kind of the overall power windings. That's a little simpler from that first diagram. Also, Mr. Schloff added this huge custom-made diode, and he described the shop that made it in Thousand Oaks is where this thing was made, and how one of them broke open and it had 4 diodes, and then it had the compensating resistor and compensating capacitor, and that was repeated about 8 times, and that's how they make the diode. He said the original diodes that came in here that served in this location were much, much smaller. But in order for him to handle the current with his now massive 14 gauge coils, he needed something bigger to do suppression. Okay, now we can get into the differences between the gold motor and the purple motor that I'm aware of, because there is a big difference. From the outside, let's see. From the outside, they look pretty much the same. Now this is comparing the gold motor with the white motor, showing the similarity among these engines that were built in '79. They all have 3 stator poles. This is what's inside the purple motor if we were to take the front cover off. What you're looking at, these big coils here, are supplementary coils. They're independent and isolated from the actual much smaller stator coils that are on the inside. This is an energy recovery system that has its history way back in the technology. Here's the rotor. Rotor looks pretty much the same as it does in the gold motor. Okay, here's the picture of those energy recovery coils with the rotor taken out. So you can see how big they are compared to the, this is the energy recovery coil, and here's the actual stator coil. Yeah, the iron, it's got this part here, this brown part, that's actually laminated iron cores. I mean, I think it's impressive. I wonder how much it cost to have them those things made in '79. As far as we can tell, this is how it was wired, sort of, and even then we don't know. I mean, it's not, they're not simple coils either. They've got this funky doodle 3-coil system. At least this is what Reggie has been able to determine from doing ohmic measurements. So, a lot more mysteries there. But to me, this resembles the topology of the Stubblefield coil. Here we have the active coil. This would be the stator. And this is those energy recovery coils on the outside. Because we're working with a non-classical energy, so all our classically trained ideas about electromagnetic induction and all that sort of stuff don't apply here. It'd be nice if they did. Okay, so this goes back, this concept of having your central coil and then having an energy recovery coil around it goes back to 1973. Where these were photos taken by Tom Vallone in 1973, but Valentine, there we go. In the corner there, which didn't show in the other picture, is this little supplementary demonstration thing. You can see here, at least I can see it, is one of those stator coils. And around the outside of this much heavier, thick wire that forms the same sort of configuration we see in the purple motor. Finally got implemented in the purple motor, but they were thinking about it, at least Marvin Cole was, way back then. And to top it off, in the 1975 patent, they actually show it. They don't describe it, they didn't say what it is or how it worked, but here's this illustration that's provided, and we'll show that in each of these poles, they got 3 separate coil sets. So 2 coil sets are in the middle, and the one much larger coil set is on the outside. To me, that shows the same sort of arrangement that we see in the purple motor, except here they were trying to get it all together in one pole piece. Once Richard Hackenberger developed this, he probably found out he needed to make it much bigger for high voltage isolation or other engineering reasons. But this whole energy recovery system might have been the foundation of the mysterious floating flux field, which is on the outside of the early motors. This is a model of the EMA4, and here you have this harness on the outside with all these coils of wire. In the patent, it shows that they are connected to the charging capacitors. So I suspect it's an energy recovery system that worked to some degree. Now you can see these things on the EMA4. This is actually the E2 motor. Originally, they only had 1 loop of coax wire for each power supply. Here, Mr. Hackenberger has doubled it to 2, so he went from one kind of coax to another kind of coax. If you look through the photographs, there's actually proof that those were all individual wires. It wasn't one coil, one continuous coil. It's actually 9 individual coils. And this is how they fit into the power supply diagram that was supplied in the 1975 patent, which is kind of different because how much induction can you get in 1 turn of coax shielded wire? So this is another indication that whatever he was dealing with here was non-classical in nature. And it permeated the motor. It came from the electromagnets, went through that 3/4 inch aluminum case, and was still able to be absorbed with that small surface area, and still have the ability to charge or partially charge these capacitors. There was a lot of static electricity. Some observers of this motor, when it was running, said that it would just draw your hair right to it. So it was kind of like a Van de Graaff generator, which a Van de Graaff generator that can do that has to charge up to about 300,000 volts or so. It's all electrostatic, but that's what they had on the case of the motor. Also, the same observer said that when this thing ran, it made a hellacious noise. Well, with all the arcs and sparks, I can certainly see that. Okay. Now we'll get down to the part that you probably all want to know, is what's the hidden secrets that I have been able to determine through my investigation of all the photos and interviews and things that I've been able to do. So these are the top 4. Okay, the first thing we were led to believe in the patent, in the 1975 patent, that we're dealing with a simple solenoid opposing electromagnets. Wrong. Here's that same picture of Hackenberger with the popping coil. That coil there's got at least 3 conductors on it. That's not a simple solenoid. Here's another shot showing another demonstration, and there, you can hardly see them, but there's 2 wires heading up here. These also have 3 conductors, wires going into them. So with that topology, this is the corrected drawing. This is kind of what they had. This probably doesn't show all of it. Maybe there's more windings. I don't know, but at least that's basically. Now, if we go back and look at the early popping coil demonstrations, before they built the motor, they had these popping coils because they didn't have the money to build the motor. In fact, it's alleged that Gray got the idea from somebody who allegedly worked for Tesla. His name was Andrei Popov, and he was either demonstrating, selling these things, or giving this thing to Gray, where you put this little coil here without the rocket on it, and you pop it off, and with the regular power supply, it would jump about 20 inches or so. You hook up the magic power supply, it would go up, hit the ceiling, and put a dent in it. This shows you that whatever kind of power they were putting into that coil a second time around was vastly different. He called it cold electricity. Well, if you take a closer look at this, you'll see that those electromagnets each took four conductors. These are not simple solenoids. Why they took 4 conductors is my guess is as good as anybody else's at the moment. Maybe we'll figure it out more conclusively as we go on. So this is my best guess of how things actually were. Here we have these are transformers here. They have a minor electromagnetic coil, which acts as a current limiter here, which also decreases the K value of the transformer so that the primary and the secondary are free to oscillate as they will. And here I show that they arc between the cores. I'll talk to that a little bit more here in just a moment. Okay, that gets us to hidden secret number 2. Okay, here's a picture from 1973 Sacconetti article showing Gray pointing to that little window. That little window didn't exist on the previous motor. In fact, it didn't exist on this motor for quite a while, at least through the early photos. They had to stop, take this thing apart, take the 1.5-inch plate off the front of that motor, send it out to a machine shop to mill that 2-inch by 3-inch window, and then put the whole thing back together. Then they had to cut a notch out of the arm that held their air compressor in order to see through it. Now the question is, what in the heck are they looking at? They certainly don't need to look at it for speed. my conclusion was they were actually looking at the arcs that were being generated between the pole faces. In fact, the air compressor there has to constantly blow air into the engine, so all the chemistries that's developed from the arcs are gotten rid of, all the nitrous oxide and that sort of stuff. So that's where I got on the idea. So then if you look at the patent, the 0 degree reference is right when these two minor magnets are right with in that position. So I assume, well, that was where the arc was struck, and then as the motor runs, the arc is stretched over this insulator, and at some point it's eventually got to quench or be disconnected. So then they go on to the next one. In the purple motor, you don't have all those electromagnets. It's a much simpler design. So if you look at this one, I figured, boy, that looks an awful lot like one is providing the arc against the other one there with that sharp point, and the other one having kind of a rounded nose. That's merely speculation on my part. But if you look back at these, the wire is actually connected with a crimp terminal to the core face for the purpose of this demonstration. So they were electrifying the cores. So getting back to the previous drawing, that's where this comes from. They discharge the capacitor through this network that charges up and produces a huge current going through this shorted secondary loop. Well then, at a particular time, after the current has had the time to reach maximum current, this circuit is broken by means of the arc being pulled apart. That is when the magic happens. That's when the non-classical event takes place, as far as I can determine. It just so happens that's the same time when the Stubblefield device does its magic. Okay, now we go into hidden secret number 3, the second battery. This is one that's been overlooked. Peter had it figured out, though. In the beginning, when they were doing the popping coil stuff, they had to have 2 batteries to run their power supply. Why did they have to have 2 batteries? Well, it was alleged so that you use the power from one, you charge it for the other, and then you switch them, is what the line was given to the observers and potential investors. This in itself was a pretty impressive device. It was a switch mode power supply that used old chopper vibrators. Today we'd be calling it a switching power supply, but it was a mechanical one back then. But he probably had it wired up differently to take advantage of getting a lot of high voltage feedback current. They show 1,400 watts of connected load here with those 10 light bulbs. I don't think those light bulbs were lit up to full capacity, because I'm sure they weren't putting out 1,600 lumens, but they lit up to the point that you could say, yeah, they're lit up. What was interesting is the light that those things put out was white. A regular incandescent lamp, when it's not running at full voltage capacity or full current capacity, kind of glows orange in that area. For some reason, these things were able to put out white light. I don't know if they were arcing on the inside or what was happening, but he had all these light bulbs hanging on the ceiling. Then he'd run a TV, an electric razor, and a drill, just to show them that this particular power could run these other things. Well, the output of this converter was measured at a radio station by one of his salesmen, and shown that it was a square wave output that operated at about 5 kilohertz. So it's pulsating DC at about 1,300 volts is what the output of this thing was that could be measured classically. I'm not sure if, I'm sure this thing here integrated some of the characteristics that they have in the motor. Originally, all the non-classical stuff did in the converter, and then Cole and Hackenberger figured out how to do that into the motor so that they didn't have to, so they could do it on site so that you can use a classical power supply, a high voltage power supply, to excite this thing. Okay, concerning the batteries, this is the early demonstration. They were going to go to market with this thing as is. Here it's running on 4 golf cart batteries. If you'll notice for this photo, this battery array doesn't have a plastic case on it. And if you're wondering, down here where the batteries go, there's a big plastic case on it. That's because when they got to the higher power levels, these things started to explode. The question is, if they were exploding batteries, why the hell didn't they get rid of them? Because Hackenberger said they only got about 67% of the energy back to recharge the battery, so they have to have this generator on there, which I believe in this photo is up there. So you have this 30 amp, 12 volt generator topping off the batteries. Well, if this thing's putting out 7.5 kilowatts of mechanical power, just put a bigger generator on there and get rid of the damn battery. That didn't happen. That tells me that battery was a very necessary component in the system of this non-classical technology. If you take a look at the battery array here, this idea that they were switching batteries back and forth is a bunch of BS, because this array is not symmetrical. Notice he's got all these taps from 0 to 14 volts, and then another set of batteries on top of that. The taps were used for speed control. So apparently the power supplies that he had, you could control the input voltage, that would control the output voltage, that would control the speed. That was their speed controlling mechanism, from my best guess. After the EMA4 came the EMA6. Now, for all those people that think that the converter element switching tube was the heart and soul of this technology, I disagree. It was an attempt. But if you'll notice, this time it's been removed. And all the switching is done by a big commentator that, let's see, can you see it on that? No. Yes, you can. The switching is done over there in the end without all those big white donuts, all the arcs. And I got pictures of that thing arcing and sparking at night. So the converter element switching tubes originally were designed to do that switching, and they didn't work, or didn't work as good. I remember when this thing was debuted, it only did 2 horsepower. Well, in order to get it to work, they had to take that out and come up with, go back again to mechanical switching. And then that's when they generated all that EMI and got pinched by the FCC. So here's the battery array here. Again, he has that multiple tap setup. It goes to a big rotary switch. That controls the speed. That controls the input to those transistor power inverters. And at the time, the CSETs were down here, and those apparently have been replaced by the ignitrons in the later version. Now, Aaron and other people have done a lot of work with the converter element switching tube and come up with interesting information, and they're working with ions, and that is a whole separate study in itself and something important in its own right. But it was not the foundation of the great technology. It was, in fact, the 75 patent shows related patents that show the method of how that switching system was supposed to work. But for some reason, it didn't work in this application, or it didn't work as well as something else could have. Okay, the gold motor, same thing. Here we got, down at the bottom, you can see 6 batteries there. You can even see taps. They needed those smaller voltage increments to work with. And this is in the 1979 era. That's the sister motor to this one. So even now, they have to have that other battery. Okay, with the photos I had at the time before this presentation, I didn't have pictures of the battery system in here, but I assume it was pretty similar to the gold motor. Okay, so this is what was shown in the 1986 patent. Now notice they're showing two batteries. By golly, they're switching them in and out. But Peter had it figured out. They're actually independent connections. Now maybe you can switch them, but it was that battery that's hooked up to that capacitor that kept blowing up. And how come they couldn't get rid of it? They had to have it there. It served a function. It provided charge carriers, or it provided something to make this non-classical technology function. Here's a schematic from the 1975 patent, and it shows a battery array that's far more complicated than that switching two batteries back and forth. So the conclusion here, there's quite a bit difference from the patent that was disclosed and what really is. Okay, so here we get down to hidden secret number 4. This is my favorite. This is my pet. Okay, according to Kenneth Hawkins, Mr. Hackenberger, at least in the 1979, and probably previous all the way back to the beginning, they used iron wire. I don't know if they used it in the primary, the secondary, or whatever, but they used iron wire. The photographs from the inside of the EMA4 motor show what looks like copper wire wound around the electromagnets. But iron wire, like this roll over here, is available copper coated. So then I don't know if they have copper coated iron wire that's insulated, so you can't tell from the outside if that's really copper wire. But it just so happens that in my studies of free energy, there's other pioneers that have used iron wire in their experiments. We already talked a little bit about the Stubblefield device. Here's one you might not be familiar with. This is the Prentice device. This is in about 1925. Anyway, he has a Tesla coil, or it can be an RF generator, running this big delay line, half a mile long. It's got to be 9 inches above the ground or it don't work. Then he has this, which is essentially a radio receiver, picking up the energy that comes off this wire. You get way more energy off this thing than you do here by a factor of like about 600 watts or so. Well, even if this thing did work, nobody's going to use it. I mean, it's kind of impossible to manage. But the key takeaway here is this wire is common telegraph wire. Common telegraph wire is zinc-coated iron wire, in this case 10 gauge. So here he's got this big line of iron wire doing his magic. Also, if we get into the Carlos Benitez project, he's got the same sort of things, a high voltage source here, but he's got it going into this arc system. And these arc electrodes are iron. They're magnetically excited, and he has another set of opposing electrodes that are supposed to break the arc apart. So we got the same sort of thing. I don't know if that was enough iron to do it or if there's more iron in the rest of the system, but there's enough iron there to convince me that it's a possibility. And it's also, it generates its event on the break of the arc, the break of that high current arc. And he shows how he taps off the energy, rectifies it, and again, sends it back to a lead-acid battery, which I believe is a necessary component in the system. Also, we got Edward Lead Scallion, who wheeled and dealed with allegedly anti-gravity. These are some of his remaining artifacts that are at Coral Castle. And if you look closely, and other people have, the wire that he's got wrapped around that bottle in the center is rusting, which implies that he was also using iron wire. So these 4 pioneers who did, as far as I could tell, legitimate work, but each one of these systems, for one reason or another, was not commercially viable, or nobody understood it, or you're all familiar with the problems. So, in my case, I figure it's an idea worth exploring. So this is my current setup here. This is a reconstructed Stubblefield coil using iron wire from the garden store and 12-gauge copper wire because they happen to be the same diameter. Well, these are wound bifilar, so you end up with this nice delay line. So you get some interesting things on the scope when you pulse this. In my case, I'm using this 25 horsepower contactor with a floor switch. So you turn it on, I'm just running, here I just show one battery, but now I've got two batteries, runs 24 volts through there. But that iron wire is resistive. It's got 20 ohms, so I can only get an amp of current through there, which I figure is far, far short of the 1,500 amps that Gray was working with. But then again, Stubblefield was only working with like a 2-volt voltage drop with his system. So I'm figuring maybe we might get lucky. And then here's the outer collection coil. That thing's got 3 Henrys of inductance in it. It's from a friend of mine. He already had it built, so that saved me a lot of work. So that's what I'm doing in my off time. So that wraps it up for the history and kind of some of the technical secrets I've been able to figure out. Now it's a good time for questions. Maybe I've explained this so good that...
Hello, okay. So your experiment there where you could only get 1 amp through the iron wire.
Right.
Okay, so if you go back to the Crosby report, they said that the front end of that thing only was 26 watts.
Right.
So 1 amp isn't a problem
Oh, probably not.
for the way the machine actually worked.
Well, they ran it into a inverter, and bumped that voltage up to a lot higher.
Yeah.
And then they pulsed it at 1,500 volts, 3,000, 5,000, I don't know what.
Right.
And I'm pulsing it at 24 volts.
Right.
So I don't think I'm quite in the window of operation, but I'm trying to find something that looks different enough so I can say, aha, here's the difference. We'll try it again and see if we get an improvement.
Yeah.
So I'm just...
The thing is that at 24 volts, the power is so weighted towards magnetism and so not weighted towards
Right.
dielectric that you're really not going to.
Yeah, I'm not in the right
you're not
window
going
of
to be in the
operation.
window
But I
there.
figure Stubblefield was able to get some action at that. I mean, he was only working
But
with 2 volts.
he had a
He had a-
mechanical make and break.
Right, well, I got a
and a-
mechanical make and break too.
Right.
Except it's only one, turn it on, boom, let it off. And his was probably oscillating at 30 to 200 pulses a second or so.
Yeah. Anyway, great. Thank you so much.
We've got a question from online. Could
All online question?
yes.
Okay.
Could some subtle, measurable, possibly ether-related parameter in the surrounding environment in which the motor runs likely affect the operation of the motor and/or other free energy devices?
Oh, I'm sure it does. It's just we don't know what any of that stuff is. We can't even measure it. We haven't even described it. We don't have any units for it. We don't know what the relationship is between its voltage component, if it has one, and its current component, if it has one, or if it even has those things. We are totally in the dark in what we're working with. Probably the spiritualist people are more advanced in this science than we are.
Do you know how many spark gaps you have in the prototype, the gray motor?
In the gray motor, well, let's see, it depends on which one. This one here, I believe they only had the one spark gap that broke the high current circuit. Now, originally, the earlier ones, they had spark gaps in the power supply, they had spark gaps in the commutator, and then they had the main power break. So it depends upon which version. But as the versions got more modern, they had fewer and fewer spark gaps. But I believe that a spark gap is necessary, just like the battery, something in that spark gap. All those other technologies I was talking about, they all have spark gaps, and they all have batteries.
So you had 2 other follow-ons. How do you quench your spark gaps? And then with regards to the iron wire, do you believe in magnetic currents? I know Ledskalonskin did. I didn't pronounce that correctly. Thank you.
Okay, let's see, what was that first one again?
Quenching spark gaps?
Okay,
Yeah.
the quenching the spark gap is very, very important. That's why this motor has to turn at a minimum of 500 RPM so that the speed at which those arcs are pulled apart is met. You don't see very many dynamic spark quenching systems. Tesla's used air. He also used rotors and commutators on a much smaller scale. Here we're working with a 12-inch motor that you can actually calculate the number of inches per second that thing is moving. And it's critical. If you look at this motor here, he's got these indices on the end that like one measures 340, 346, 333. He's measuring these things in increments of 3 degrees to determine where the best point is to quench that arc, or how long it takes to quench the arc. You probably have to start quenching the arc. You strike the arc, but you can't quench it until several milliseconds later when the current has reached its peak. My replicated Stubblefield coil with all that iron wire in there measures 20 henries. So the rise time of that current is pretty slow on the secondary. But anyway, it's done with physical separation, and apparently there's a minimum speed. You can go a lot faster than 500 RPM, but you got to go at least 500 RPM to get this thing to quench properly. And then the question of the iron wire was what?
With regard to the iron wire, do you believe in magnetic currents? I know Ed did.
Ed Leedskalnin of Coral Castle.
Yes.
Yeah, I've read his work and I can't understand it. I believe, yes, we're dealing with classical engineering dynamics here when we're talking about transferring power from the primary to the secondary. And yes, we have a magnetic component there. But the magnetic component is minuscule compared to the forces that are generated from this radiant event when it takes place. In fact, if you calculate how much magnetic force you can generate in this motor, you can't generate anything because there's no iron there, hardly. And it's an open core thing. The actual flux between those poles is minuscule. You can't and there's so little iron that it saturates. Where in the heck did all that torque come from? Well, it didn't come from classic magnetic repulsion.
Any other questions online or?
A couple more comments. No spark gaps in his motor of today?
No, there's the spark gap in between the poles.
Okay. And then the last one, could the motor run at the Coral Castle?
Could it run at the Coral Castle? Well, if it was working, it could run anywhere as far as I know. However, you can't hook this thing to ground. It's got to be isolated. The battery, that's why it has to have the batteries. Just like John Bedini said, this particular energy, if you hook it to ground, all of it goes to the ground because that's where it wants to go. It'll go through the positive wire, it'll go through the negative wire. It's just gone. So that's why it only works as an isolated system.
Thank you, Mark McKay.
Thank you very much for coming.